Hi guys, today I am going to show you how to make a linear bench power supply like this. The entire enclosure is 3D printed. In the front panel you can see this is the voltage knob and this is the current knob. These are the two binding posts for connecting the external load. This is the display unit to display voltage and current reading, and here is the output power switch. In the bottom you can see a USB socket so that you can plug in your USB gadget into it. On the back panel you can see this is a IEC socket which is consist of a power input socket and a fuse along with a rocker switch. To test the power supply unit, I have to first plug in my AC mains. Then switch on the power switch. You can see the LED is glowing, and you can also hear the fan sound inside the enclosure. As well as on the front panel you can see the voltmeter display is also working. To check the voltage reading, you can turn on the voltage potentiometer. You can see the voltage is gradually increasing. If you turn the voltage knob to the maximum position, the voltage is around 31.8 volt. To check the current reading, I have to connect a external load. For external load, I am using a lead acid battery. First, plug in the banana plug. Now connect these wires to the battery terminal. Be sure the polarity is perfect. First, set the charging voltage. Set it to around 13.5 volt. Yes, it's okay, 13.6 volt. Now I have to set the charging current. Slowly turn on the current knob. Yes, the current reading is now showing. It's around, it's too much high. Yes, it's 0.72 ampere. It is pretty perfect for this 7.2 ampere hour lead acid battery. To confirm the current reading, I am going to use my clamp meter to check it. You can see the clamp meter reading is 0.72 ampere, and on the power supply unit this is also 0.72. That means my power supply unit is working perfectly. Now see the wiring diagram. Power coming from the AC mains go to the transformer, then it is stepped down to 24 volt AC which is connected to the PCB input. This 24 volt AC is rectified by using this 4 diode. Then the rectified DC contain lot of ripples which can be removed by this smoothing capacitor. This DC voltage is not regulated. This can be regulated by using a regulation circuit. Then the voltage and current can be changed by using this 2 potentiometer. The 24 volt DC supply is stepped down by this buck converter unit. Then the potentiometer is set to give the output of 5 volt which is connected to the USB terminal. The power output from the PCB is goes to this rocker switch, then goes to the display unit, then goes to the binding post for connecting the external load. I desolder the LED on the PCB, then connect wires to a external LED on the front panel. Now we can move to assemble the kit. The kit contains a nice PCB. The components are not properly segregated. So initially I segregate into different categories like resistor, capacitor. Then I measure the resistance value by using my multimeter, then place it separately. In the PCB you can see all the components are named perfectly. So you can place the component according to the name and their values. Then I start my assembling process by soldering the components. I always start with the components which have smaller heights like resistor, diode, then capacitor, then so on. After placing all the resistors, I solder them. Then I trim the legs by using a nipper. Before soldering the bridge diode, you have to bend the leg with the help of a nose plier. I use some heatsink compound to the metal part of the power transistor. Then I screwed it into the heatsink. Similarly, I apply heatsink compound to the other transistor. Then I attach to the heatsink. After soldering the transistor, I mount the DC fan with the heatsink. Before soldering the JST connector to the potentiometer, I inserted some heatsink tube. Then I solder the connecting wires to the potentiometer and I use a lighter to shrink the tube. The enclosure is based on the Thingiverse design Ultimate Box Maker. The front and back panel is modified on Autodesk Fusion 360. Then I print the enclosure by using my Creality CR10 3D printer. I mount the USB socket by using some hot glue. I installed all the other components to their corresponding holes on the front panel. I place the PCB on the PCB fits on the bottom cell. Then I mount it by using 4 screws at the corners. Similarly, I place the transformer on the base. Then I screw it by using some washers. After installing all the components on the enclosure, I wire all the components according to the wiring diagram. I connect the PCB output to the front panel as shown in the wiring diagram. After completion of my wiring, I close the front and back panel, then cover the top cell. Hope you have enjoyed my video. If you like this video, don't forget to share and like. To subscribe my channel, hit the subscribe button below. Thank you so much.